So we're doing notes 8.1 day 2. This is dedicated to Jamie. This notes. If you wanted a shout out, so it's for Jamie. So graphing a quadratic. We're gonna. Yesterday we talked about what a quadratic is, and we did that while we were factoring. Quadratic, it starts with an x squared. So y equal to x squared, where your first one or your a term is equal to 1. So there's a 1 in front of here. This is what we call our parent function, was on the notes yesterday. And why we call it a parent function? Because all other quadratic graphs are what we call a transformation of x squared. So if something's transforming, it's changing. So every graph is a change from this basic graph. And we have some nice simple steps that we can use to accurately graph these quadratics each time. So your first step is to make a table of values, and we're going to make a, not like a table you put things on, but an XY table. Those are inputs and outputs, which give us ordered pairs, which are x comma y points. And our last step is just to draw kind of our smooth curve through the points. And it's going to look like each time, if this is our kind of our graph, it's going to look like a U shape. And we have a special name for that U shape, a parabola, or some, I like to call it a parabola. I think that's funny, just parabola. So if you ever hear me say that word, that's what it means, just the shape of the graph, a U shape. So let's go through these steps, and we're just going to start off using graphing the most basic parent function, this y is equal to x squared. So we're going to make our xy table, boom, boom, boom. And what you'll do is you're going to fill in, to start, things for x. All of your x values, they're all inputs. And what you get out for y's, those are your outputs. So for today, on the notes and the homework, what you're going to use as your inputs, I want you to always use, go -2, -1, 0, 1, 2. That's always going to be your inputs. And you are going to use those to get your outputs by plugging this into your equation. So y is equal to, if we have an x squared, we're going to plug in a -2 and square it. Let's say -2 squared. This is -2 times -2, which is, what did I do? 4. So that will go in our table, a 4. So then we say, okay, what do we get out when we input a -1? Or we could say y is equal to -1 squared. So that's -1 times -1. That's a +1. That will go in our table. We do the same thing for 0. What happens if we square 0? Well, 0 times 0 is going to be 0. So we say 0 squared is equal to 0. We'll do the same thing for 1 and 2. Y is equal to 1 squared, which is 1. 2 squared, which is 2. Oh, sorry, it should be 4. I had a brain fart. So, I just took all my inputs, plugged them in, and got a bunch of outputs. So let's go through now and graph using our table that we made. So again, these are our x coordinates, these are our y coordinates. So we use them to match up on our x and y. So I just like to go top to bottom, -2, 4. That means we go over 2 and up 4. over 2, 1, 2, 3, 4 is right here. This one you go over 1, up 1, over 1, up 1. Here we're right at the center, 0. 0, 1, 1, over 1, up 1. 2, 4, we go to the right 2 and up 4. Then you want to draw a kind of a nice smooth curve through the 3 of them so it doesn't look like a V, but it looks like a U. And there we go. So at this point already, you'd be like, oh, Mr. Scully, that's a lot of work to do just to graph this. I'm going to show you kind of a shortcut that you could use based on a pattern that we have for quadratics. So yesterday in the video, you learned about what an axis of symmetry is. For something to be symmetrical, that means if you were to cut it in half, both sides would be equal. So like a circle is symmetric. The letter A, a capital A, is symmetric. A parabola will always be symmetric as well. So this red line is kind of like the crease of our paper that we were to fold on top of each other, they'd be the exact same. And if we look at our table now, if our vertex here, remember our vertex is kind of our lowest point or our highest point. So this is your vertex, which is right here on our table. Our table is symmetric as well. Notice from this vertex, it's 1, 4, and there's also 1, 4 as well. So if we were to fold this table in half, it will be symmetrical as well. The numbers will always, for our outputs, will be symmetrical. So I would really only have to figure out what 4 and 1 is. I know this is always going to be 0. Then I know this is going to be 1 and 4 as well. And you'll see that pattern as we go through the next few, so you can convince yourself that this will always work. So we're going to graph now 2x squared. So this 2 is being multiplied by the x. And we'll talk about remembering order of operations once we set up this table here. So use your same numbers, go -2 to +2. And then when we're plugging in all of our inputs, so we plug in -2, y is equal to 2 times -2 squared. Notice that I'm doing two things. Whenever I'm plugging in a number, I'm putting parentheses around it. That's important, especially when you're using a calculator. If you try to square a negative and you don't have parentheses around it, you're going to get the incorrect number. Once you have parentheses around it, you have to do this part first. Order of operations say we have to do anything with an exponent first. So we have to raise this to the power of 2, then multiply by 2. So this is 2 times 4, which is equal to 8. So an 8 will go right here. We'll do the same thing for -1. We say y is equal to 2 times -1 squared. That's 2 times 1, which is equal to 2. I know my 0 is always going to be 0, because if I square 0, it's still 0. Then I multiply 0 by any number, it stays 0. So I could just fill this one in right away. And then our pattern, our graph is symmetrical. So I could say, I don't even have to do my other calculations. This is going to be 2, and this is going to be 8. And when I graph that, we're going to still have a symmetrical parabola. If your parabola isn't symmetrical or doesn't look like a U, you either graphed it wrong or you got the wrong numbers out. So you can go back and check. But this one will look like -2, 8 will be up here. -1, 2 will be right here. 0, 0, and then it's symmetrical through this line. So I can just mirror it to the other side. This will be 1, 2. This is 2, 8. We can draw our line through it. And now we have a kind of a narrow U. And our U was a little bit wider last time. Now it's a lot more narrow. All right. What I'm going to do is I'll do the next one on the board, and then you're going to do the 4th one on your own, and that's where we will stop notes. All right, so I'll do one, then you do one on your own. This next one, only reason it's tough and why we're talking about it is because we have a fraction. 1/2 you could write as a decimal, you could write it as 0.5. It would work the same, but I'm just going to keep it as a fraction because I like fractions. So make our table x comma y. We have -2, -1, 0, 1, 2. And we work with our inputs to get our outputs. 1/2 times -2 squared. That's 1/2 times 4. So multiplying something by 1/2 is like dividing by 2. So this will give us out 2. We do the same thing for -1. Y is equal to 1/2 times -1 squared. It's equal to 1/2. This will be just a 1. So we get a decimal. We get 0.5, which is okay. Decimals don't hurt us. 0.5, I know 0 is going to be 0. And then I just use the fact that it's going to be symmetrical. If arrows help you draw arrows, you know that this is going to go to this spot, and then this is going to go all the way down there. So this is 0.5, and this is 2. Think of it as if you look at a sideway, it looks like a rainbow. So we graph this. 0, 0. If it's a decimal, you just have to approximate where it would be. 0.5, that's half of 1. So we're going up like half a box. And then 2, 2, we go over 2, up 2. And then we mirror it on the other side. So now our U, or our parabola shape when we draw it, it's kind of stretched out. It's not as narrow. It's wide. That's all we're going to do today. All right, so you go through and do the next one on your own. I'll put up the answer. Let's say I'll put it up like after 2 minutes. The only kind of hint that I'll give you for number 4 as you try it is that it's a y is equal to a -1 times x squared. So there's a -1 in there. So remember order of operations as you go through. It's 2:35. At 2:36, 2:37-ish, I'll put the answer on the board. You can check. Make sure you have a good understanding of this. This year we're going to do this a lot. Did you finish number 4? Do number 4, then go. I don't see it. I can see it from here. I think my eyesight's that bad. Around what?
Around the X. There be something.
Yeah, so I just put the parentheses I put in there to show that I'm plugging in a number.
Oh.
Yeah.